Hi, I am today in Uplatz. Today we are going to discuss about Introduction to AUTOSAR Part 1. In an introduction to AUTOSAR, AUTOSAR consulting consists of 10 core partners, 45 associate members, 51 premium members, general OEM, generic Tier 1, standard software tools, and connected industries. What is AUTOSAR? AUTOSAR, Automotive Open System Architecture, middleware and system level standard jointly developed by automobile manufacturers, electronic and software suppliers, and tool vendors. More than 100 members, motto, cooperate on standards, compete on implementations, reality, current struggle between OEM and Tier 1 suppliers, target, facilitate portability, composability, integration of software components over the lifetime of the vehicle. The software standardization of the components and interfaces, the software implementing the automotive functionalities in encapsulated in software components, standardization of the interfaces is central to support scalability and transferability of functions. Any standard conformant implementation of software component can be integrated with sustainability, reduced effort in the system. The standardization could be developed incrementally towards level of abstraction, functional aspects, implementation aspects, level of decomposition, broad degree of decomposition of the functional domain, high degree of decomposition of the functional domain, level of architecture, definition, terminology, standardized, database, partial description of interfaces without semantics, complete description of interfaces without semantics, complete description of partial definition of functional domain, complete definition of functional domain. Functional domains, the specification of functional interfaces is divided into 6 domains: body, comfort, powertrain, chassis, safety, multimedia, telematics, man-machine interface. The domains could be differently handled into intellectual property rights, issues, and decomposition domains. In the first phase of AUTOSAR, only in the domains body, comfort, chassis, and powertrain results can be expected. All others have low priority in the first phase. Now, AUTOSAR architecture, gateway, basic software, RTE, AUTOSAR establishing 1, 3, ECU 1, 3, AUTOSAR establishing N, deployment tools, ECU descriptions, system constraint descriptions, virtual functional bus, AUTOSAR SMC, establishing 1, 2, 3 to N, establishing description. AUTOSAR SWC, the AUTOSAR software component encapsulates an application which runs on the AUTOSAR infrastructure. The AUTOSAR SWC has well-defined interfaces which are described and standardized. SWC description for the interface as well as other aspects needed for integration of the AUTOSAR component. Software components, AUTOSAR provides a standard description format, SWC description. Virtual function bus, VFP. The virtual function bus is the sum of the all communication mechanisms and interfaces to the basic software provided by AUTOSAR on an abstract technology independent level. The connections for a computer system are defined. The VFP allows a virtual integration in an early development phase. Establish a description of establish 1 to N virtual function bus. System constraint and initial description. In order to investigate AUTOSAR software components into a network of ECUs, AUTOSAR provides a description formats for the system as well as for resources and configuration ECUs, ECU description, deployment tools, system constraint description. AUTOSAR architecture mapping on ECU. AUTOSAR defines the methodology and tool support to build a complete system of ECUs. This includes the configuration and generation of runtime environment RTE and basic software AUTOSAR on each ECU. Runtime environment RTE from the viewpoint of AUTOSAR software component. The RTE implements the VFP functionality on the specific ECU. Development tools, ECU 1, AUTOSAR establishing 3, RTE basic software. Basic software, the basic software provides infrastructure for execution of the ECU. A fundamental concept of AUTOSAR is the separation between application and infrastructure. An application in AUTOSAR consists of software components, interconnected connectors, rain light condition, automatic light control, ALC, outside brightness, outside brightness, passenger door, driver door, coming home, leaving home, CHH, light request, if light request, light master, LM. The generic AUTOSAR component concept, component software components, sensor software components, special case composition, logical interconnection of components package as a component. In contrast to the atomic software components, the components inside the composition can be distributed over several ECUs, ECU abstraction, complex device driver, AUTOSAR services. Each AUTOSAR software component encapsulates part of the functionality of the application. AUTOSAR does not prescribe the granularity of software components. Depending on the requirements of the application domain, an AUTOSAR software component might be a small reusable piece of functionality such as a filter or a large block encapsulating entire subsystem. The AUTOSAR software component is an atomic software component. Atomic means that each instance of the AUTOSAR software component is statically designed to use one ECU. Implementing AUTOSAR software component, AUTOSAR does not prescribe how an AUTOSAR software component should be implemented. A component may be written or generated from a model. Shipping an AUTOSAR software component, a shipment of an AUTOSAR component consists of a complete formal software component description which specifies how infrastructure must be configured and for the component, and an implementation of the component which could be provided as object code or source code, software component description, component implementation. The AUTOSAR software component description contains the operation and data elements that the software component provides and requires to describe using the board interface concept, the requirement on the interface structure, the resources needed by the software component, memory, CPU time, etc., information regarding the specific implementation of software component. The structure and format of this description is called software component template. A source code component implementation is independent from the type of microcontroller of the ECU and the type of ECU on which the component is mapped. The AUTOSAR infrastructure takes care of providing the software component with a standardized view on the ECU hardware. The location of the other components with which it interacts. The component description defines the data or services that it provides or requires. The component does not know if they are provided from components on the same ECU or from components of a different ECU. The number of times a software component is initiated in a system or within one ECU. AUTOSAR component description levels. The highest level, most abstract description level is the virtual function bus. Here, the components are described with the means of data types and interfaces, ports, and connections between them, as well as the error of the components. At this level, the fundamental communication properties of the components and the communication relationship among each other are expressed as software components, composition, and interfaces. Description of the components on RTL level. The middle level allows for behavior description of the given component. The behavior is expressed through RTE concepts, RTE events, and in terms of schedule level units. For instance, for an operation defined in interfaces on the VFB, the behavior specifies which of those units is activated as the consequence of the invocation of that operation. Runnables, events, interaction with the runtime environment. Description of the components at the implementation level. The lowest, most concrete level of description specifies the implementation of a given behavior. More precisely, the schedulable units of such a behavior are mapped to code. The 2 layers above constrain the RTE API that a component is offered. The implementation now replaces this API component implementation resource from the plane of software components. What is software component? A reusable self-constrained artifact implementing a function with given properties of the component structure, behavior, resource, and non-functional requirements. Component structure key concepts, information idea and encapsulation, software component structure, behavior, the resource, non-functional requirements. Software component data ports, asynchronous, no transfer control, port out, double kept or speed, 14 unit vehicle index, provided interfaces, does not suffice for encapsulation, software component, required interfaces, software component. Component structure, key component, information handling and encapsulation. Data pools, the methods, signatures, includes call, transfer and control, double get route speed, unit with index, internal giveaways, includes model FSM, asynchronous data pools, asynchronous transfer control ports, out, double get route speed, 14, unit with index. That is a behavioral aspect. Then component structure, key concept, information handling and encapsulation. We have precondition port invariant internal behavior decided by contract. Then key information handling and encapsulation, tasks and resources description. Components dependencies are described in forms of interfaces and ports. No internal dependencies may exist. Therefore, components are in theory exchangeable as long as they implement the same logic and provide the same public communication interface to the remaining system. Once a component is defined with the help of software component template, a new component type has been defined. Such a component can be used an arbitrary number of times within the system as well as in different systems. Components are developed against a virtual functional bus and abstract communication channel without direct dependency on ECUs and communication machines, and we must not directly call the operating system or the communication hardware. As a result, they are transferable and can be deployed to users very late in the development process. A component has been defined ports through which the component can interact with other components. A port always belongs to exactly one component and represents a overall point of interaction between a component and other components to define the services or data that are provided on or required by the port of a component. The AUTOSAR interface concept is introduced. The AUTOSAR interface can be client-server interfaces, defining a set of operations that can be invoked. Sender-receiver interface for data-oriented communication. A port can be our port provided interface, capital P port provided interface, or port required interface. When a P port provides an interface, the component to which the port belongs and provides an implementation of the operation defining the client-server interface, generates a data described in the data-oriented sender-receiver interface. When our port of a component requires an AUTOSAR interface, the component can invoke the operations when the interface is a client-server. We read the data elements described in the sender-receiver interface. Eliminate the communication patterns, client-server, sender-receiver interfaces specify which what information is communication transport, which services with which arguments can be called by client-server communication. The format of the description of the interface is in the software component approach, including also data types that can be used and interface compatible. In the detailed behavior of a basic communication pattern is specified by attributes with those attributes. Example, the length of data queues and behavior of the receiver, talking, non-blocking, and gender, cell cyclic, etc. can be defined. The server is a provider and the client is a user of a service. The client initiates communication, requesting that the server platform is a service, transferring the parameters if necessary. Then sending a server waits for incoming communication request from a client performs the requested service and dispatches a response to the client's request. The direction of initiation is used to categorize whether an AUTOSAR component is a client or a server. A single component can both client and a server depending on the software decision of the service request is initiated, and until the response of the server is received, client can be blocked, synchronous communication, non-blocked, asynchronous communication. An example occurs in communication in the composition of three software components and two connections in the VFA model. AUTOSAR software client, client 1, client 2, service request, service requested, service provided, AUTOSAR server, software component server. Model for asynchronous distribution of information, where a sender distributes information to one or several receivers. The sender is not blocked. Asynchronous neither expects nor gets a response from the receiver. Data are controlled. The sender just provides the information and the receiver decides autonomously when and how to use it. It is the responsibility of the communication infrastructure to distribute the information. The sender does not know the identity or the number of receivers. An example of how sender receiver communication is modeled in AUTOSAR sender, sender information, receiver information, it's a receiver 1, receiver 2. A virtual representation of components, ports, and interfaces in a component model. AUTOSAR software component, port characterized by port interface, provide port interface client server, require port interface render receiver, provide port interface render receiver, attributes connectors, require port interface client server connector, attributes provide port interface and client server. Two components are eventually connected by key. You have a port of one component to be compatible with port of the other component. The model shows that it is allowed to define a component without any ports, which seems counterintuitive. This is only reasonable for components that are totally self-contained. Whether the ports are actually compatible is described by a port interface, as will be shown later. These ports interfaces require services or data elements that are required and provided by the respective ports. A port interface has two single attributes called each service. This flag indicates whether service or data described in the interface is actually provided by AUTOSAR services instead of another AUTOSAR component. AUTOSAR components communicate via the virtual function bus. They need ways to express recognition capabilities with respect to changing data, which is currently possible through two kinds of attributes. Communication attributes allow specifying parameters of the communication that affect the generation of the RTE or the actual communication taking place at that time. An example of such an attribute is the aforementioned transfer time over a connector. Application level attributes allow describing properties of exchange data that do not affect the RTE generation, but indicate to the developer how data needs to be processed. An example for this kind of attribute is a flag whether the data is filtered or raw. Sensor actuator components are special AUTOSAR software components which encapsulates the dependencies of application on specific sensors or actuators. AUTOSAR infrastructure takes care of hiding the specifics of microcontroller. This is then in the MCA the microcontroller abstraction area, which is part of the AUTOSAR infrastructure running on the ECU. And the ECU electronics is handled by ECU abstraction, which is also part of the AUTOSAR software. Typical conversion process from physical signals to software signal. Example, car velocity and back, a car light, car velocity, physical interface, sensor, electrical interface, 0 to 20 milliampere, ECU electronics, electrical interface, 0 to 5 ECU, microcontroller, peripherals, hardware, applications, software component, application software component. To get these set up. Sensor component, actuator component, ECU abstraction, then MCAL, HLDI software, then correlate actuator, ECU electronics, then UC peripherals. The AUTOSAR infrastructure does not hide the specifics of sensors and actuator. The dependence on the specific sensor and actuator are dealt with sensor actuator software component, which is a special kind of software component. Such a component is independent of the ECU on which it is mapped, but is dependent on the specific sensor and actuator for which it is designed. For example, a sensor component typically inputs a software representation of the electrical signal at an input pin of the ECU. Example, a current produced by the sensor and outputs the physical quantity measured by the sensor. Example, for speed, typically because of performance issues, such components will need to run on ECU to which the sensor actuator is physically connected. A virtual function bus is the abstraction of AUTOSAR software component connection of the entire vehicle. The communication between different software components and between the software components and its environment, hardware, driver, OS, service, etc. can be switched independently of any underlying another. Example, communications system, the functionality of VFP is provided by communication patterns. In the for VHP, the view ports of AUTOSAR components, complex device ECU abstraction AUTOSAR service can be connected. Complex device drivers, the ECU abstraction AUTOSAR services are part of the basic software. AUTOSAR software interface, CA firmware, standard interface, API, VFP, and RTL element. VFP bus, application software component, AUTOSAR interface, actuator software component, AUTOSAR interface, Sensor software, AUTOSAR applications, AUTOSAR interface, compressed image standards, AUTOSAR interface, issue abstraction, standards AUTOSAR services. ECU software architecture, and AUTOSAR software component, FPGA interfaces, ECU firmware, standard software, API 2, VAPI and API 1, RT and API 0, API 3 private interfaces, ECU basic software provides, operating system, standards interface, AUTOSAR environment, basic software, standards interface services, standard AUTOSAR interface, standards communication standards interface, AUTOSAR interface, issue abstraction, standards interface, compressed image AUTOSAR interface, application software component, AUTOSAR interface, software component, software component, AUTOSAR interface, application software component, AUTOSAR interface.